Here was an interesting question, and it's all about compound interest, really. So we just go and try and interpret what's going on in the question. I usually draw a little picture. Here's the year 2000. Xavier starts a new job. His annual pay increases each year by 2.5% of his pay the previous year. So I'm already thinking times 1.025, right? Compound interest to increase by 2.5% is to find 102.5%. So I've gone straight for it. The other thing missing is actually what salary Xavier actually had in the year 2000. But let's just put a little box there for now, and let's worry about that later. Okay, great. So we've got the year 2000, we've got 2.5% sorted out from the question. Good. Now let's look at part A. Calculate the number of complete years. Oh, I haven't spelled that right. Not to worry. It took Xavier's pay to be 30% greater than his pay in the year 2000. Okay then. Well, I think this is to the power of n, right? And then that would give me to the 2000 plus n years, because that would be n years. But then I think what we're saying is that same salary needs to be 30% higher over here. Now, isn't 30% higher just times by 1.3? So isn't the equation we want, we kind of need the whatever this starting salary is, right, times 1.025 to the n, we have to be equal to the same starting salary times by 1.3, right, 30% higher. Now, you've probably guessed it that it doesn't actually matter what the salary is in the box, because you're going to divide both sides by the starting salary, right? So that starting salary is just going to disappear, and the question is 1.025 to the power of n. We want to match that as a 1.3. Okay, so these are called about the multipliers, and on the right hand side we have an increase by 30%, so the multiplier is 1.3, and here we have a yearly multiplier of 2.5%, but obviously compounded to n years. We have to solve this equation. Now, because it's a calculator paper, we're just going to go straight to our calculator, right? So get out your TI Nspire, and then menu, algebra, numerical solve, and just type in the equation. It's 1.025 to the exponent n, and that's equal to 1.3. And when you try and solve it, enter, it says too few arguments because the calculator needs you to tell it, comma, n. It likes to know which variable you're solving for. All right, 10.63. Let's just go back to this guy here, 10.63. So the solution to this is n equals 10.63. But it does say calculate the number of complete years, right? The number of complete years. So we know that n has to go up to 11 years, all right? Now, once you've got this idea of the multiplier going forward, part B is just that little bit easier. So here's 24, the year 24, and here's 25,215, and here's 22, and here's 27. So you can see from 24 to 27, it's times by 1.025 to the power of 3, and that will be this total here. And of course the total here times 1.025 squared will get you to the 25,215. Okay, so that's key. I will call this A here, I will call this B here. So you can see that A times 1.025 squared equals to 25,215, and you see here 25,215 times by 1.025 cubed equals B. Okay, I'll just go reach for our calculator again, and so we've got 25,215 times by 1.025 to the exponent of 3. Let's just write that down. B is 27,154 to the nearest dollar. And then we obviously have to do a little division, so 25,215 divided by 0.025 squared. That equals, oh, look at that, beautiful, 24,000. And the question says, oh, find the increase from here to here to the nearest dollar. So you can see it's a 24 to 27,000, it's $3,154 increase, all right? So the key is to understand the idea of the multiplier with a single step size. A 30% increase is times 1.3, a 2.5% increase is 1.025, and powered up to n is, compounded each year. For the part B, set the picture up nicely, going in one direction. Going in this direction, it's multiplying, of course. So therefore, going back the other way would be dividing.